Hello everyone, this is Srinivasan from RMDEC Engineering College. In this video lecture, I'm going to talk about radial basis function network. The radial basis function or RBF neural network is the one form of neural network, and here it uses the radial basis function as the activation function. It's one form of multi-layer perceptron. It has exactly three layers. The first they are input layer, one hidden layer, and output layer. So here the hidden layer uses the radial basis function as activation functions. The output layer is linearly combines the outputs that are generated from the hidden layer to produce the output. Look at the important principle for solving problems through RBF networks. So we take the non-linearly separable data sets. See, the radial basis function neural network uses the radial basis function activation function to draw uh, different lines, different circles with the different radius. See, look at here, it chooses one center point, and with the help of the center points, it draws the circles by increasing the radius slowly. So when it finds the suitable radius to differentiate the data points of one class from another class, it stops its training. So the radial basis functions draws uh, circles of different radius gradually, and when it identifies the arc that differentiates the data points or circle that differentiates one class of data points from another class of data points, it stops training. That is, the convergence will be stopped. See, as I said earlier, radial basis function has the exactly three layers: one input layer, one hidden layer, and one output layer. So input layer collects the inputs from the data, and it passes to the hidden layer. The hidden layer uses the radial basis function as an activation functions to generate its output. The output of the hidden layer is passed to the output layer. The output layer some of the weights as well as the inputs, okay, coming from the hidden layer to determine the output layer. So this particular diagram shows the architecture of the RBF network. We quickly summarize the workflow of RBF neural network. It starts with the input layer, input vector. The vector is fed into the input layer. So each element of the vector is passed to one input neuron. The network has one hidden layer in which the radial basis function is used as an activation functions. So these radial basis neurons, okay, has a center, and they measure how close the input to the center. They do not do this using the special function called the Gaussian transfer function. The output of this function is higher when the input is close to the neuron center and lower when the input is far away. The outputs from the hidden layer are then combined in the output layer. Each node in the output layer corresponds to a different category or class of data. The network determines the inputs class by calculating the weighted sum of outputs from the hidden layer. The final output of the network is the combination of these weighted sum, which is then used to determine the output. And the RBF network is also used for solve the multi-class categorization. And this particular function is an example for radial basis function neural network. It is also called the Gaussian function. The Gaussian distribution is used to determine how close the point is to the center. So look at the advantages of RBF network. It is easy to generalize compared to the back propagation neural network, and it is useful to solve problems in the data set that have complex nonlinear distributions, and it is easily interpretable compared to BPN. So look at the disadvantages. First one is the dimensionality of the data set will affect the performance of RBF network, and The performance of the object network is highly dependent on the placement of centers, and it is vulnerable to overfitting problems. Thanks for watching this video.